Hello, algebra students. Mr. Lawrence here. And the first thing we're going to do is, some of you are having a real hard time with this, Rads with variables. You're just not thinking about the right way. Look, we need to know when a variable is a perfect square. We are not, are you listening to this, Kristen? We are not looking here. No, do not look here. Do not look here. It's a perfect square if we can find the same number multiplied by itself to get this as an answer. Like, for example, is 9 a perfect square? Yes, it is, because 3 times 3 is 9. But we're not looking at the exponent. The exponent isn't necessarily relevant. It doesn't matter whether 14 is a perfect square. What you got to ask yourself, is there a number, x to a certain power, times itself, x to that same power, that equals x to the 14th? And that would be 7 and 7. So you see, x to the 14th is a perfect square. Okay? Is x to the 18th a perfect square? Well, ask yourself, can you fill in the blanks with the same number? Not with a different number, with the same exponent, and get x to the 18th. Yeah, it is a perfect square. How about x to the 24th? You should be catching on by now, because this isn't the first time we've seen this, that this, 24th, would be x to the 12th times x to the 12th. So yeah, these are all perfect squares. This, however, x to the 7th, is not a perfect square, because no matter, sorry, shouldn't put doesn't equal, is not a perfect square. It's not a perfect square because there's no two factors of x to the 7th that I can multiply and get the same number times itself to get x to the 7th. Restricting myself to integers, of course. So, like if I did x to the 6th times x to the 1st, well, that equals x to the 7th, but they're not the same number. How about x to the 5th times x squared? Nope. X to the 4th times x cubed? I don't have to list anymore because they're just going to repeat and switch places. So x to the 7th isn't a perfect square. I could think about it as a factor of the perfect square in another number. I could say x to the 7th is the same as x to the 1st times x to the 6th. And x to the 6th is a perfect square. X to the 1st times x cubed times x cubed. But notice, I don't look at the exponent and go, oh, it's not a perfect square, therefore the numbers. No. I break it down. All right, so let's see here. Let's take the rad of x to the 22nd. Is it a perfect square? You bet your boots. How do I know? It's even. The exponent is even. It's going to be a perfect square. I could break it down into x times what power? What number times its, what power times itself would give me 22. X to the 11th times x to the 11th. There's my date. So therefore, rad of x to the 22nd is x to the 11th. Now, this answer is not totally correct yet. We're going to talk about that in 1 minute. Let me try this one. X to the 80th. Well, it's even. So I'm going to get x to the 40th times x to the 40th. And so the f's, or the rad of x to the 80th is going to be x to the 40th. Now this green one here, it needs the absolute value of ours. But the blue one doesn't. Why? Because a rad is the positive square root. Watch what happens if I put negative 1 in here. I'm going to put the rad of negative 1 to the 22nd power. And outside that, if I forget the absolute value, I'm going to have the negative 1 raised to the 11th power. This will be a positive answer. This will not. Try it on a calculator. Raise negative 1 to the 11th power with parentheses. You'll get a negative answer. This will equal negative 1. But we only want a positive square root. So to ensure we get a positive square root, we put the absolute values around it. Now if I do the same thing over here, I'll get rad of negative 1 to the 80th and negative 1 to the 40th. They're both going to be positive numbers. Try this one. You'll get a positive 1. So that's why we don't need the absolute value. The absolute value is restricting us to positive answers. Okay, How do we do x to the 15th? Well, it's not a perfect square as is. So I'm going to rewrite it as x to the 1st times x to the 14th. Now, x to the 14th can be rewritten as x to the 7th times x to the 7th. So these two are going to be out front and an x to the 1st inside the rad. And there you go. This should start getting simple. Don't make this difficult. We don't care if 15 is a perfect square. We care if x to the 15th is a perfect square. Now it's not, so I rewrote it as x to the 1st times x to the 14th. X to the 14th is a perfect square. X to what power times itself is 14, while x to the 7th times x to the 7th. And so I take the rad of x to the 14th, which is just plain old x to the 7th. A rad on the inside is just a plain old x to the 1st. I don't have to worry about absolute values because I can't get a negative under here. If x is -1, I get an imaginary number. Yeah, if I do this, -1 to the 7th, rad -1 to the 1st, I get an imaginary number. Try it on your calculator. If you're on a grapher, it'll say non-real answer. Okay, how do I do x to the 17th? Tell you what, I want you to pause the video now, and I want you to try x to the 17th. Break it down. If you haven't tried yet, please pause the video. All right, here comes my solution. I'm going to rewrite this x to the 1st times x to the 16th. 16 is even, so I'm going to think about it as x to the 8th times x to the 8th. Take the rad of that, and I will get x to the 8th, rad x to the 1st, and there you go. All right, let's look at two that are a little bit more complicated. They're actually easy. It's just 4 problems in each. So the first thing I'm going to do is rad 48, and I'm going to break 48 down into 16 times 3. 16 is 4 times 4. So for just the 48 part, I'm going to have a 4 out front, and inside the rad, I'm going to have a 3. Now the x to the 8th is going to break down as x to the 4th times x to the 4th. The rad of that would be an x to the 4th. There will be no x's inside the rad. The y to the 13th is going to break down as a y to the 1st times a y to the 12th. And the y to the 12th will break down as y to the 6th times y to the 6th. I'm going to take the rad of that. I'll have a y to the 6th out front. But there will be this y left inside. Now the z. It's going to be a z to the 7th times a z to the 7th. Take the rad of that, except that odd exponent outside, even exponent inside, tells me I'm going to need the absolute values. So this was even, this was odd. We need the absolute value. And there's your answer. I've got a really long rad here, and I don't need it to be that long. So if I want, I can shorten it up. And my answer is this. Okay? All right, here we go. 500. I'm going to think about it as 100 times 5. 100 is 10 times 10. This is going to break down into 10 rad 5. So I'm going to have a 10 out front. I'm going to have a 5 under the rad. Those left the house. 5 was stuck. X to the 30th is x to the 15th times x to the 15th. How am I doing that so fast? I'm just taking half of 30. That's all I'm doing. I need an x to the 15th outside, but whoop, 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 whoop. I had a 30 and a 15, even, odd. I need absolute value bars around it. Okay, now my y's. I'm going to go y to the 1st times y to the 30th. Y to the 30th breaks down as y to the 15th times y to the 15th. I know because I just did it. A y to the 15th is going to come out front, but there's going to be this y here left inside. I don't need absolute value bars around it because y can't be negative because that would cause the whole thing under the rad to be negative. All right, finally, let's see here. Z to the 32nd is going to be Z to the 16th and a Z to the 16th. So there's going to be a Z to the 16th out front. There won't be anything inside. And there is my answer. All right. Here is your video quiz. Which of the following are perfect squares? Let's see here. 15, 25, 169, x first, x to the 9th, y to the 20th, z to the 50th, and let's do a k to the 18th. So you can write them all down and circle the perfect squares. You can only write down the perfect squares, however you want to do it. Okay, that's question 1. Determine which of those are perfect squares. Number 2, you have to simplify both of the rads. Rad 12, x to the 50th, y to the 40th. B is rad 50, x to the 11th, y to the 18th. Don't forget to use absolute values when appropriate. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.